Hello, Miss Coltrane. I just had a question about one of the problems on the physics review. I left one of my answers blank because I didn't feel like I could fully explain it in a page. And we were kind of running out of class time, and a lot of other people needed your help too, so I decided I would just send you a video asking my question. So the problem I'm talking about is the train problem. The first part was pretty self-explanatory. You find the momentum of a first train, which is mass times velocity, and I'm using arrows instead of trains because I'm bad at drawing. So we have mass times velocity. That's the momentum for the first train, right? And then the second part of the problem was finding the force when it collides with the train that has 1/2 times mass times velocity. Okay? And the problem said they collide for t seconds. Okay? And so I had a suspicion about this problem, and so I was explaining my suspicion to Lily, and she explained to me that to solve the problem, what she did is F times t equals 1/2 times mass times velocity, and she just solved for F. Okay, so, but I explained to her that forces are equal and opposite, right? So if F is mass times V over 2t, then the force acting on this train is going to be the same force acting on this train, and it's going to equal mass times V over t. And as you can see, the only way these two things are equal to each other is if mass is 0, which then we would have no trains. And if velocity is 0, then the trains wouldn't be moving. And besides that fact, we actually have values for mass and velocity. So those can't be equal to each other. And so then I was thinking maybe we need to use a different equation. So this is impulse, then we can do f times t equals, impulse is also change in momentum, so we do mass times velocity, mass times final velocity minus mass times initial velocity, okay, and mass times initial velocity. And so I kind of just assumed that the final velocities were 0 because it didn't really state in the problem. All it said was that they collided for 0.3 seconds, I want to say it was. And so I just assumed that the final velocity was 0, right? And so if force times time equals change in momentum for the first train, then it's going to equal change in momentum for the second train. So we're going to have whatever the second train's mass is times the second train's final velocity minus 1/2 of the first train's mass times the first train's final initial velocity. That's an I, I'm sorry for my terrible drawing. And this should be 2, and that should be 1, 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 okay? But if the final velocities are 0, then this is nullified, because 0 times anything is 0, right? But now we're back to square one, because now our equation looks like f times t equals negative mass times initial velocity, which also equals 1/2 times mass times initial velocity. And so that was my question. I genuinely wanted to understand if we use another equation for this, or if maybe my base theory behind my question, maybe in this case the forces aren't equal and opposite, but I imagine that wouldn't be the case because forces are always in equal and opposite, I think. So that's just a question I had about how to solve this, and so thank you for listening to me.